Okay, good evening. This is Professor David J. Delos Reyes. Okay, it's August 28, 2023. The time is 11:34 p.m. It's still Monday evening. Okay, my discussion for tonight will be college algebra, and this will now be on the graph of a natural logarithm functions. The last time around, I discussed the so-called graph of an exponential function, most especially the so-called e to the x. For tonight, I will be presenting the graph of the natural logarithm of x. Okay, the base of the natural logarithm is e. The value is around 2.71828, the one used by electrical engineers. Okay, let's proceed. My previous discussion from the last lesson under college algebra is lesson number 44, and for tonight it will now be college algebra lesson number 45. We are running smooth. Okay. So the title of the topic for tonight will be the graph of logarithmic functions, especially the so-called natural logarithm function. We'll concentrate on the natural logarithm function. So for those people who are taking up electrical engineering, you will not be hard up and the so-called graphing of the natural logarithm functions, like in the calculation of sag of transmission lines or the San Francisco Bridge, something like that. We will be using the natural logarithm function. Okay, let's proceed. If originally we are given the logarithmic equation y equal to the logarithm of x with the base of a, where a could take a real value, okay? For tonight, if we let a equal to e, and this value is approximately 2.718288183, something like that. Okay. If we let a equal to e, and the value is 2.718288183, okay. If we try to go back here, y now will be the logarithm of x. Okay, we are following this. We replace that a by e. Okay, but under the study of natural logarithm, if the base is e, okay, to simplify writing, it is just simply written as a natural logarithm of quantity x. Okay, we don't write anymore the e. We just place ln, meaning natural log of x. So if from this, if we try to simplify this one, y now will be equal to the natural logarithm of x. And that is actually the so-called natural logarithm function. Okay? And our problem for tonight will be on how to graph this. We are just only studying algebra, so at least we now know what's the graph of y equal to natural logarithm of x. So when you go to the so-called study of differential equations, okay, you will not be hard up in the study of the concept on why the graph is something like this. Okay, let's try to graph the function. We will compute for the intercepts. Intercepts, meaning a graph should pass by the x-axis or y-axis. So let us determine if the graph y equal to the natural logarithm of x passes through the x-axis or to the y-axis. We will know it. Okay. So for the intercepts, there are two intercepts, right? The y-intercept and the x-intercept. So we shall start with the y-intercept. For the y-intercept, the point should pass through the y-axis, right? So the x at that moment will be 0. So for the y-intercept, if we set the value x equal to 0, okay, what will come out? Y will be equal to, we'll follow this, y equal to the natural logarithm of 0. And if you try to bring out the natural logarithm of 0 by using the calculator doesn't know what's the natural logarithm of 0 because it is undefined. Okay? It does not exist. So, the natural logarithms of 0 by using the calculator or by using our knowledge, it should be undefined. It's not within the capability of the calculator to bring out the natural logarithm of 0. That's why it is undefined. There will be no value. So when x equal to 0, there will be no value for y, and we will place it here, no y-intercept. So meaning to say, the graph y equal to the natural logarithm of x did not cross the y-axis. Okay? It didn't pass through. Okay. Let's compute for the x-intercept. X-intercept meaning where the graph passes through the x-axis. Okay. For this graph here, it will be here. Later on, I will tell you why it is 1, 0. Okay. So to compute for that x-intercept, we will let y equal to 0 because any point that lies on the x-axis, the ordinate is actually 0, right? The ordinate is 0. It does not go up, it does not go down, so it should be 0. So for a point to be on the x-axis, okay, y should be 0. So we place it here. When y is equal to 0, okay, what will be x? What will be the value of x? If x is 0, what will be this value here? Okay, and by using our knowledge of algebra, we will compute for the value of x. So, we'll follow this, we'll put the value y equal to 0. So, 0 will be equal to the natural logarithm of x. We must have to compute for the value of x without this natural logarithm sign here. And to eliminate this natural logarithm, we must have to take the inverse antilog of both sides. Take the antilog, take the natural antilog of both sides. Meaning to say, you get the base of the natural logarithm, you raise both sides of the equation from e. So, if we try to take the antilog of this equation here, it will be e to 0 because the base of this is e, right? So, to eliminate this one, we must have to raise both sides to e raised to something like that. So, the left-hand side, it will be e to the 0, and this should be equal to e to the natural logarithm of x. And e to the 0 is 1. Because any number, whether plus or minus, it should be 1. So the left-hand side is 1. And for the right-hand side, okay, use your knowledge of Calculus algebra. The antilog of the natural logarithm of any given function is just the given function. So e raised to the natural logarithm of x will be x. Or rearranging, x now will be equal to 1. So meaning to say the abscissa where the graph passes through the x-axis is at the location 1 and 0. So I place it here. When x is 1, right, this one, the ordinate will be 0. So this point here is the point where the graph y equal to the natural logarithm of x passes. And the coordinates is actually 1 and 0. But for the y-axis, from our computation, it didn't pass through, right? It didn't cross the y-axis. Okay? What's next? So we now know that the graph passes through this point here. For the right-hand portion, okay, hold on. For the right-hand portion, this one, the one that goes to the right. What will be the variation and the problem and the value of y? Okay, what will be the variation? Will it go down or will it go up? Okay, how about the one to the left of 1 and 0? As the value of x approaches 0, what will be the variation in the value of y? Will it rise up or will it go down? Okay, we could solve those ones. So with reference to the location 1 and 0, which is actually the x-intercept, we place it here. As x approaches 0, y will approach negative infinity. It's negative infinity. Okay? It's like this. As the point moves from 0 or from 1 going to 0, right? The value of y decreases. Why it decreases? It's like this. If we try to bring out point plotting, we start from 1, we'll go 0.9, approaching 0, 0.8, 0.7, 0.6, 0.5, 0.4. And what's the number that's very near 0? There are so many. So supposing we assume 0.001. At the location x equal to 0.001, if we try to compute for the value of y, the value of y is a negative value. Negative. So meaning to say, as the number approaches 0, the value of y approaches negative infinity. Why negative? Negative infinity is a very big number, but if there is a negative sign, this is a very small number. So this should be a very, very, very small number. Right? But it does not go to 0. That's why the y-axis is considered the so-called vertical asymptote. Okay? Because this will be the curve. Okay? And the y-axis is actually tangent to this curve, but they don't touch each other. That's why the y-axis is considered the so-called vertical asymptote. Right? Or how about the value of x going to the right? As x approaches positive infinity, meaning to the right, any value greater than 1, meaning to the right. So this is plus infinity. Okay? What will be the value of y? We can compute for the value of y. Again, by using the point plotting. It's like this. As x approaches positive infinity, I place it here, y approaches also positive infinity. Meaning, as y moves from 1 going to the right, the value of y, whether we like it or not, will also increase. It will also approach positive infinity. But the variations is not so much, because it is like this. When x is equal to 2, the value of y is 0.693. When x is equal to 4, if we try to place it in this equation, the value of y will be 1.3, positive 1.3. That's why this is plus. Okay? When x is equal to 6, the value is plus 1.8. So as you try to notice it, this is actually increasing, right? 1.3, 1.8, 2.2, okay, 2.3. It increased, but it's not so much, but it's still, it will approach the value positive infinity. That's why I place it here. Any value to the right of 1 and 0, as x approaches infinity, y will also approach infinity. It will grow big also. As you increase x, the value of y will also increase. So this is from plus to plus. Okay? So the graph of this will be, if you try to graph this, at x equal to 2, the value of y is this one. As x is equal to 4, the value of y is this one. As x equal to 6, this one. The value of y is this one. It increased, but it's not so much, but it is getting bigger, right? When x is equal to 9, the value of y is this one. And when x is equal to 10, the value of y is this one. So if you try to place it when x is equal to 1 million maybe, okay, 1 million, what will be the value of y? The value of y will also be in the millions, okay? That's why when x increases, whether we like it or not, for y equal to natural logarithm of x, y should also increase, okay? So the graph of this will be this. It will increase, okay? For the one that is what they call this to the left of 1 and 0, whether we like it or not, the values are getting smaller. Negative 0.105, negative 0.223, negative 0.356, negative 0.51, negative 0.69, negative 0.91, negative 6.9. Okay? The value is increasing, but the sign is negative. That's why it is decreasing. Decreasing. Okay? And as x approaches 0, the value of y will also approach a very, very small value. But it will not be equal to 0. Okay? Because this is a vertical asymptote. So the graph of this and the equation will be this. So when x is equal to 0.9, very small, this is the value of y, negative. It is below. When x is equal to 0.8, this is the value. Right? When x is equal to 0.5, this is the value. Right? It's getting smaller. When x is equal to 0.001, 0.001 is already very near 0. And the value is negative 6.9. Okay? Supposing x is equal to 1 over 1 billion. 1 over 1 billion is a very, very small number. Right? But it is not yet equal to 0. And what will be the value? It should be a very, very small value also. That's why I place it here. As x approaches 0, the value of y will approach negative infinity. Very, very small value. Very, very, very small number. And as x approaches positive infinity, the value of y will also approach a very big value. So this should be a very, very, very big number. Right? That's it. So at least we now know from our textbook, they place it there, domain and range. So for the domain, it is the value of x. Domain refers to the value of x. And for the range, it refers for the value of y. Okay? Will it go up or will it go down? For the domain, it is going to the left or to the right. For the range, does it go up or does it go down? So when we see domain, it refers to the abscissa, and for the range, it refers to the ordinate. So at least we now know what are intercepts, domain, range, and vertical asymptote. The vertical asymptote is actually the y-axis. It is this, right? And the equation is actually x equal to 0. The equation is x equal to 0. If the straight line that lies on the y-axis, the equation is actually x equal to 0. And that is considered to be a so-called vertical asymptote. So the graph for y equal to natural logarithm of x, it will be this. Going down, but as we go down, okay, the graph does not cross the y-axis, except maybe at infinity. And for the value, the one on the right, as we increase the value of x, it also goes upward. Okay, it will increase. That's why this is positive infinity. Okay, that's it, guys. That's the graph of the so-called y equal to the natural logarithm of x. That's why the topic for tonight is the graph of logarithmic functions. And for tonight, it will be natural logarithm. This is natural logarithm. Okay. We don't mind other bases, okay? Because this base A here could take any value. To concentrate on the natural logarithm, we will let this A here equal to E. And that E is 2.718 approximately. Okay, that's it, guys. So for those of you who are taking up electrical engineering, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJDelosReyes. If you want to share it, please click share. Okay, the next time around, we will be solving problems involving logarithms. Okay, there are equations that involve logarithms, which is either common logarithm or natural logarithm, or any logarithm with any base maybe. So the next time around, it will be solving problem involving logarithms. Okay, good evening from Los Angeles. Professor David J. DelosReyes.